Hey guys, welcome to Mr. Hoppy's Calculus, where today's lesson will be differentiation. In today's lesson, we are going to be going over the product rule, the quotient rule, the chain rule, and also trig functions. Let's get into the lesson. Alright, so before we get into the meat of the lesson plan today, let's quickly review the power rule. So basically what this rule is you times the outside number by the x's power, and then you subtract 1 from that x's power. Let's look at a few example problems to quickly review this. So keeping in mind what we just did, we can look at this problem right here. We have y is equal to 2x squared minus 4x. So the first step of the rule was to times the outside number by the exponent here. So 2 times 2, and then there we would get 4x, and then keeping in mind then we have to subtract 1 from the exponent. So it'd be 4x to the 1, which is still 4x. So then we have this other number right here, minus 4x. And then here we will do basically the same thing. This is basically 4x to the first power, so we times that, minus 1 times 4 is 4, and then it'd be x to the 0, which is otherwise known as just 4. So in the second problem here we have 7x cubed minus 5x squared. So again, times the outside, we get 21x, drop the exponent, so that's squared, minus, and then we have 5 times 2, which is 10, x to the first power. So then we get y is equal to 21x squared minus 10x. Alright, so now since we just finished that little review on the power rule, we can get into the first part of the main lesson. And we are starting out with the product rule. So basically what this is it is used to find the derivative when you are multiplying two or more quantities together. So then basically we are given this formula, the derivative of g of x times f of x. So you're multiplying g of x times f of x and taking that derivative. So what this is equal to is g of x times f prime of x, which is the derivative of f of x, all of this times together, plus f of x times g prime of x. So basically what you're doing here is you each have a g and an f of x and an f prime and a g prime of x, but basically you're taking the opposite of what you have here and then taking the prime of that, and then we're going to add this all together. This may seem a little confusing at first, so let's do some practice problems really quickly here to clarify this up. Alright, so now since we reviewed the formula for the product rule, let's do this example problem here. So we have y is equal to 2x minus 1 times 5x plus 3. So basically what I would first do is recommend that you choose an f of x and a g of x to represent your equation. So just to make this a little bit easier, I'm going to write this 2x minus 1 is going to be my f of x right here, and this 5x plus 3 will be my g of x. Okay? Now, thinking back to the formula, it's f of x times g prime of x plus g of x times f prime of x. So basically what we're just going to do is write that out. So let me quickly write that out again, just so you guys can remember. We have f of x times g prime of x plus g of x times f prime of x. And now since we have our formula here, we can plug in what numbers we have. So for f of x, we've got 2x minus 1 times, and our g prime of x, well, what is the derivative of g of x? Well, thinking back to the power rule, we can do, this is 5x to the 1 power, so that's 1 times 5, which is just 5, okay? And so we've got, this is our first part right here, then we're going to add g of x which is, let's do the bracket here, g of x, so plus 5x plus 3 times, and then f prime of x, the derivative of f of x, that's 2x to the 1, so 1 times 2, so times 2. So right now we've got this whole equation, and let's simplify it down. So times this by 5, we have got 10x minus 5, put our brackets in, plus, and then times over here by 2, 10x plus 2 times 3 is 6. This is what we've got here. And now we can just simplify it even further till we get 10x plus 10x is equal to 20x, and then negative 5 plus 6 is equal to 1. So our final answer to this problem right here is equal to 20x plus 1. Alright guys, the next part in our lesson is the quotient rule. So basically what this is the opposite of the product rule. So what you want to do is find the derivative when you have two or more numbers, but instead of multiplying them, you want to divide them. So basically what the formula is for the quotient rule is low d high minus high d low all over low squared. So you may be kind of confused at first, like, oh, what does this mean? What you want to think about in this way is low, meaning there will be a lower part of a fraction, the denominator, d, which stands for the derivative, and then high, the numerator. So you have basically the low, the derivative times the derivative of the high, minus the high times the derivative of the low, all over then low squared. So when you're thinking of the quotient rule, the easiest way to come up with the formula is to just think of this jingle. Low d high minus high d low all over low squared. If you're still a little confused, let's go into an example problem. Alright, so this example problem for the quotient rule is y is equal to x squared over 3x minus 1. So again, let's remember, low d high minus high d low all over low squared. So let's write this out. We have low, which is our 3x minus 1, the denominator. Let's write that, 3x minus 1. D high, so times the derivative of high, which is x squared. So times it by the outside, which is, this is a 1x squared, so that'd be 2x. Low d high minus, put this in brackets here so we can remember to subtract all this, minus high d low. So minus the high x squared times the d of low, which would be then 3. So this is our function that we have here. So let's quickly simplify this here. We have got 6x squared minus 2x, got that there, and then minus 3x squared. We can further simplify this, and we can subtract 6x squared, so then we get 3x squared minus 2x, and this is our final answer. Alright, so the next thing in our lesson today is the chain rule. This is a very interesting rule, and it'll be coming up a lot over the course of calculus. So basically what the chain rule is, you take the derivative of the outside and then you times it by the derivative of the inside of a certain function. So let's go to the examples and see what this looks like, and then let's figure out the problem. Alright, so here we have our chain rule example. We have y is equal to 2 times 5x squared plus 4, all to the 5th power. So if we remember, the chain rule is equal to the derivative of the outside times the derivative of the inside. So obviously, outside would be the 2 and the 5, and the inside would be 5x squared plus 4. So let's take the derivative of the outside first. 5 times 2, that is equal to 10. And then basically this 5x squared plus 4 acts as an x. So we can just bring this back down here, 5x squared plus 4. And then the 5, that has to go down one number, 4. So we just took the derivative of the outside. And then to finish the problem here, we have to times it by the derivative of the inside. So what is that? We have the derivative of the inside is equal to 2 times 5, so that's 10x, and then the derivative of 4, since it's just a number, is equal to 0. So our final answer here is equal to 5x squared plus 4 to the 4th power times 10x. And that is what we have. All right, and the last part of our lesson are the trig functions, taking the derivative of a trig function. Now, normally if you were to take the derivative of this, you would think, well, the same rules apply, whether that's the quotient or the product, power, chain, etc., etc. These are almost irregular, so in a way you just have to memorize these. So basically these are the 6 trigonometric functions that you need to memorize so that your problems on your homework or the test in your calculus class, you do not get tripped up. So the first one we have here, the derivative of sine of x is equal to cosine. The derivative of tangent of x is equal to secant squared. And the derivative of secant of x is equal to secant x times tangent of x. Over here, we have the cosine of x, derivative of cosine of x is equal to negative sine of x. The derivative of cotangent x is equal to negative cosecant of x squared. And then cosecant of x is equal to negative cosecant x times cotangent x. Now, if you look at this, you may possibly see a pattern. They are organized in a specific way that over here on the left side, we have your trig functions, and their derivative are going to be equal to a positive number, where over here on the right side, all of the numbers are going to be equal to negative. So in a way, you have to both remember this, what they equal, and if they are negative or not. So the best way to picture this is to picture the ones that create a positive offspring and the ones that create a negative offspring. Well, thank you guys for tuning in to Hoppy's Calculus. Hopefully this video cleared up the topic. Happy differentiating!